Hey guys, Mrs. McBride here. I'm here on page 11. Been a long time since I've talked to you. Just kidding. Okay. I'd like to do a couple of these problems with you, and then I want you to do the rest on your own. So I want you to finish off page 11 and also page 12. I'm trying to flip this page here. Page 12. Let's not do number 9 though. No, number 9. I'm just not feeling it here. Okay? So we can do the rest of them though. And if you get stuck, do your best and we'll talk about it tomorrow when I see you. Okay. This first problem says a 2-kilogram block is pulled to the right by a force of 10 newtons. The coefficient of static friction is 0.35 between the block and the ground. I want you to find the force of friction. Okay, we're going to draw the friction vector and we're going to figure out, does the block move, how, or why not? Okay, now for every case, so I'm going to write it up here. In each problem, okay, and this is just for today, Fn is going to equal mg. Okay, so that's for all of the problems that we're going to do today. This isn't always the case, but for today it is. Okay, so the first thing I need to do is find the force of friction. So I know Ff equals mu Fn, and then I know that Fn equals mg. So I'm going to say Ff equals mu mg. So I'm going to say that Ff equals mu 0.35 times my mass, which is 2, times my g, which is 10. Okay? So take a second and pause this video. Do that math. What do you get? I don't know. What do you get? You get 7? 7, I hope. Let's go with 7. 7 newtons. Okay? So now it says, draw the friction vector on the free body diagram below. Hopefully you're saying to yourself, hey, I know that friction opposes motion, so I know that friction is going to go this way. My next question is, does the block move? Okay? Well, what do you think? Does the block move? I'm going to say yes. And I know that because if this force is 10 and this force is 7, then this is larger than the force of friction, so it moves, right? So yes, it moves because 10 is larger than, oops, let's say 10 is larger than 7, okay? So how does it move? Well, we can say here that the sum of the forces equals ma, right? Okay, well, what's the sum of the forces? Well, if I have 10 going this way and 7 going that way, the sum of the forces would give me 3, right? And my mass, oh, it would help if I was on camera, and my mass is 2, and my acceleration is what we're looking for, right? Okay, doing this, I should find that this moves with an acceleration of 1.5 meters per second squared. Okay, let's do another one together. Let's take a look at number 2. This one says an 80-kilogram person standing on waxed skis slides across level ground covered with snow. What is the force of friction acting between the skier and the snow? Okay, well, I will tell you that the coefficient of friction, because I'm looking it up, okay, on the Regents reference table, they give you a whole list of different coefficients of friction. Okay, so since we're moving, right, and we've got waxed skis on snow, and again, I'll show this to you tomorrow, okay, I can see my coefficient of friction, okay? So to find the force of friction, I'm again going to say Ff equals mu Fn. But I know that in this case, Fn always equals mg. So I'm going to say this is mu mg. So I've got 0.05 times my mass times g. Okay? I'm getting my calculator out here. 0.05 times my mass, which was 80 times 10. Okay, all right, looks like the answer is 40 newtons. Okay, that's the force that's acting between the skier and the snow. Okay, let's do one more together and then I'm going to send you on your way. A 0.2 kilogram copper plate is resting on a steel surface. Okay, so if we're at rest, we're looking for what type of friction? Hopefully you said static. Okay, we come over here. Let's see, we said copper on steel. And we need to find static. So we've got here that the coefficient of static friction is 0.53. Okay? So to find out how much force is required to keep it moving, again, we're going to say FF equals mu Fn. Okay? And we know that Fn is equal to mg, or we've got 0.53 times 0.2 is our mass times 10. Okay, going to our calculator, 0.53 times 0.2 times 10. This should give me a value of 1.06 newtons. Okay, here's what I'd like you to do. I want you to try 4, 5, 6, and then on the back, you're gonna try, where are we? 7, 8, and 10. Okay, Mrs. Borzik will have the answers, so check your work with her as you go. Have a wonderful day, and I will see you tomorrow. Bye, guys.